Well, now we're going to add radicals, square roots. Let's see, so negative square root 5 plus 4 root 3 minus 3 root 3. Well, these two are like terms. This is not. So this equals, nothing's happening with the square root of 5. It stands alone. But we've got 4 root 3's minus 3 root 3's is just going to leave a root 3. And we're done. That's our answer. Well, here's another case of adding radicals. And let's see, and this is negative, this equals negative 3. And root 18 is the same as the square root of 9 times 2. And we've got a minus root 8, and here we have 2 root 8 and 2 root 8. So that's 4 root 8 minus root 8 is going to be, these are like terms, is going to be plus 3 root 8. And now this equals, and the square root of 9 is 3, so that's negative 3 times 3, and root 2 plus 3. Oh yes, square root of 8. That is the same as 4 times 2. 8 is. And so now we have negative 9 root 2 and plus, and the square root of 4 is 2, and 2 times 3 is 6 root 2. And what do you know? We have like terms here. So that's going to be 9 minus 6 is negative 3 root 2. And we're done. Well, here's another set of radicals to add up. And notice we have two like terms here. 3 times the cube root of 135 minus the cube root of 135. Will that equal 2 cube roots of 135 minus 3 times the cube root, and 81 is the same as 3 to the 4th. Now we have 2 times the cube root of, and by the way, 5 goes into 135 27 times. So that's going to be 27 times 5, because 5 times 20 is 100, and 5 times 7 is 35. And they sum to 135. And this becomes the cube root of 3 cubed times 3. That's not too clear, is it? 3. Okay. So that's going to be 2 times, and by the way, the cube root of 27 is 3, so we can get a 3 out of that, out from under that radical. And we still have cube root of 5 left. And now minus the cube root of, oh, let's see, we can get it, the cube root of 3 cubed is 3, and we've still got the cube root of 3 left. So let me rewrite that. 2 times 3 is 6, cube root of 5 minus 3 cube roots of 3, and they are not like terms, so that's the best we can do, and we're done.